For this problem, we can write it down like a column method like this, okay? And you have ones, tens, and then decimal point there, and then this is a tenth, so it would be 1/10. And then this is a hundredths, like this, right? This is pretty much like a method for the column method, right? And we have read one article about the column method, right? And then this is very, traditional classroom. They will use this method for teaching, right? And then you might have a student to fill in a number 7.8. What does this mean? That means you have 7 ones and 8 tenths. Is that right? Right? Place value. So focus on the place value. Now, what about 13.09? What does this mean? The meaning is I have 1/10, 3 ones, and then what about 0? 0, 1/10, 0 tenths, and then therefore it will be 900, right? 900. So adding up the total, and then this method is good for what? For general learner or slow learner, right? So adding up the total column method and writing up the place value, that's 8 and then 0, and then carry on here. So the answer, here the decimal point has to 99. Right? So the answer is 20.89, right? This method is good for what? It's good for everybody. And even the slow learner, need to give a meaning behind what is the meaning for the place value. Okay. Now what about quick learner? Remember that we talk about decompose and compose method, right? And quick learner, they can do mentally process, right? So 7.8, if I like to decompose 7.8, what should I do? Can I decompose this as a 7 and 8 tenths, right? So I want to decompose 7 and 8 tenths. Right. And what about 13.09? So can I decompose as a 13 and a what? 900ths, right? Alright. So basically, you decompose like this, and you can process with a mental computation like this. Process the mental computation like this. And then you have a 20 for this, and then this is 8900ths, right? And then therefore, add together will be 20 and then 8900ths, right? This is a what? This is like a mental calculation process. Now, eventually, this picture will be gone. They can look at this, and they get the answer. They can decompose. Whole number add together, decimal add together, and add all together, that will be the answer. But this method is good for what? I would say this is good for quick learner, right? Quick learner, we have to tell them the method of decompose and compose, right? Now eventually, the pictures, up here, the thinking routes, will be gone, right? Because they can look at the number, got an answer, thinking about mental. Does that make sense to you in terms of teaching? It's for slow learner and quick learner, right? Yes. I think that quick learner deserve learning this way, okay? Alright? And this is for everybody, of course. You have to learn the place value, of course, okay? Number 2. 69 divided by 6. Divided by 6. Alright, so here, in this review, we also review the method we learned before, right? Alright, We also review the method we learned before. The long division. Remember that? Do the long division. What did I tell you for long division? What we should tell the student? Put down the 1 and there and 6. And then what's next? You can either put down 0 as a placeholder, or you can put out the arrow sign like this. Is that right? Right? So 6 minus 6, 0. 9 bringing down 9, right? Or, and then this is 6, that will be 1, and then be 6. And then, all right, finish, yes or no? No. We have to continue, right? Continue for college level. And continue. Now, what's the next place value? This is a decimal point, this is a decimal point, right? So therefore, what numbers we supposed to fill in this? 0. Is that right? And then 0 is also bringing down, is that right? Right? If you're not good at division, this is the time you can relearn, okay? And then 0 bringing down, so therefore, what number we're supposed to fill in this? Well, 5, yes. 5 times 6, 30. So therefore, 11.5, right? Or you can either put a 0 as a placeholder. Does that make sense to you? Long division, right? And then I think a lot of people, you learn long division, right? Now what about, can we do this problem with scaffold method? Scaffold method is different. Scaffold method is similar like this, but scaffold method gives a place value. When we say this is 1, right? 6 times 1, right? And we say 6 times 1, oh. But actually this is not 1, this is a 10, this is a 1. And then this is 1, this is a 10th, right? So each one is place value, but long division, kind of confusing for people, right? That's why we have another alternative way called scaffold method. And scaffold method, remember that? I'm not gonna review for scaffold method. If I like to take 125 divided by 5, right? And what is a scaffold method? Scaffold method, we start here, the number is how many? 2? 2? No, not 2. Not 2. 2 is for long division. We start one number. We take a 5 times how many? We not take 2. We take a 20, is that right? Remember that? This is a scaffold method, right? And then that gives it a meaning. 5 times 20, which is 100. And minus this, and in this method, you don't need any arrow sign or 0 as a placeholder, right? This method is more clearly place value. You take a 5 times 20, you get 100, right? So therefore, I have 25 left over, is that right? And then next, I fill in the number 5 times 5, yes, that's 5. Right? And then that's 0. And add it up the total to the top. So the answer will be 25. Remember that? This is called scaffold method we learned before, right? Can we do the same thing for scaffold method? Can we do the same, So here, I want you to take a minute. Try, if I like to do the scaffold method, it would be 69 divided by 6. Take a minute. So this time you are looking different, right? You not take a 6 times 1, right? Instead of a 6 times how many? 10. Yes. You take a 11? Yeah. But you have to take a 10 first, right? So because you start with the tens, and then the ones, and then 1, and then 10th. You start with the order of this instead of 11. Okay? This is a scaffold method. You start with the tens, and then ones, and then 110, and so on, right? So now we start with tens, right? So therefore, we got a 60, is that right? So now we have a 9. 69 minus 60, which is 69, right? So what's the next number we have to fill in this? 1, yes. Now 6 times 1 is a 6. So we have a 3 left over, right? So therefore, next place value, 0. Then this is a 0. What's the next place value? We have to fill in this. Because this is tens, ones, next one will be what bit? 0.5. Yeah, thank you very much. Does that make sense? So 0.5 times 6, that's why we have 3. And then add it on the total from here to the top. So therefore we have 11.5. Did you get 11.5? But did you see the difference? Did you see the difference? Here is giving more meaning. Here is not much meaning for this. Is that clear? Right, good. And then that's the scaffold method, right? And we talk about short division, right? Can we do short division? Yes, we could do short division. Remember that? 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we want to do short division is what? We want to do short division. I want to divide it by 3, right? And then this is a 4, and this is a 1, and this is a 1, right? 3 times 1, oh, that would be 3. And then we have a 1, right? And what is this 1? We put on the top, remember that? Remember that? So we have a 15 divided by 5, and 3 is how many? 5, and what's the next one? 2, and what's the next one? 2, 2, 2, and remember 1, right? Where's the 1? 1 going here, right? 18 divided by 3, how many? It would be 6, right? And then this one. So that is the short division, right? For quick learner, right? Can we do the same thing for short division for this method? I want you to take a minute, see if you can find using the short division, okay? Can you use the short division and finding out the answer is still 11.5? Short division, actually you don't have to write a lot of things there, right? The short division again is good for what? Good for quick learner, right? What about the junior learner or about the slow learner? We can go into this method or this method. Okay. All right, are we ready? 6. So that'll be 1. Is that right? And then next, all right, put on 1 again, right? And next place value, have to put on a 0, right? Don't forget to put on 0, right? So therefore, we have a 6 there, and then where's the 3, right? But actually, we put in my mind, no, 3 will put in there. Is that right? So therefore, that'll be 5 times 6, 30. So 11.5. Does that make sense to you? Okay. And this is the methods, we learned before, right? Next problem. Problem number 3. See, when doing a problem like this, I like the conceptual understanding is more important than procedure. But both you need to know, right? And then both is important. And probably you have to learn in the past, just know how to do the procedure instead of conceptual understanding. 19 minus 5, 13. All right? 19 minus 5, 13. Now let me ask you, what is the first step? What is the first step you want to do this problem? What is the first step you want to do this problem?
The same denominator.
You find the same denominator, right? And we call this as what? We call this as a common denominator, right? And what does the meaning for common denominator? This is a denominator. This is a numerator, right? This is a numerator. This is a denominator. You have to find the same denominator, then you can do any operation, right? That is the first step you have to do, right? Now, why? Why this is important? And many of you don't know how to do it. You don't know why we need to find common denominator. Why? Does anybody know why?
I mean, you can't add them together unless they're the same numbers, so it's like.
Why?
Okay.
Right. Well, we have a reason, right? So let me show you, addition. Okay, actually, the addition and subtraction is the same, okay? One half plus 1/4. Okay? And again, we need to show the same common denominator, and then we can do any operation here, right? So 1/2. 1/2, basically, can I say, one half of pizza, like this? Yes or no? Yes. And quarter, it's a quarter of pizza like this? Yes or no? Right. Now, if I don't do the common denominator here, right? And I can see this is 1, this is 1, so the answer will be equal to. And then I can see 1, 2, 3, 4, 5, 6. So therefore is equal to our 6. What's wrong here?
It's not simplified.
Not simplified. Yeah. If you simplify it 1/3, but the concept is not right. You take a 1 plus 1, 2. You take a 2 plus 4 equals 6. No, we're not supposed to do this. We're not supposed to do this, right? Because they are different quantity, right? 1/2, even though it's 1/2, you have this piece of the pizza. And this one has small piece of pizza. You can say this is 1, but you cannot say this is another 1. It's different 1, different quantity. So you cannot say I take a 1 plus 1 equal 2. No, that's a misconception, right? And how can we fix this? All right. Take your color pencil, please. Draw these 2 pictures, okay? Take your color pencil. I will show you how with a color pencil, okay? Are we ready? All right. We say common denominator, right? We say common denominator. So therefore, we have to change these 2 into a common denominator, right? Take your color pencil, please. I'm going to show you. This is the magic, and it's the truth. All right. Single line will help you understand. Do we have a common denominator? Yes or no? All right. We have a common denominator, so therefore this changes into 2 order of 4. Is that right? And then this remains the same on both. So therefore, look, do they have the same common denominator there? Yes or no? So that's why we put out a 4 on the bottom. This is the meaning of a common denominator. Does that make sense to you? Now next, how many are there on the top? Why we need the common denominator? Similar, if you want to do the subtraction, if I want to do the subtraction for this, I want to take this one, subtract this, right? So therefore, we still need a common denominator to taking care of this, right? This is the what? 2 out of 4, right? This is a 1 out of 4, right? So therefore, how many it is? If I subtract this much, how much left over? And then I got a 1 plus. Does that make sense to you? Right? And that is the meaning of common denominator. Okay? They have to make it as a same portion in order to have operation. If they don't make a same same portion, then therefore you have a big one and you have a small one, right? It's not to compare, not to do anything for operation, right? Similar for here. I want to make this as a common denominator. What should I do? What should I do? What should I do to make this a common denominator? You times 13 there, is that right? Right? And you times how many there? You times 9, so therefore they make it as the same portion, right? And then you times 13 there, don't forget. You have to times 13 on the top, make it as equivalent, right? You times 9 there, you got times 9 for the top, make it as equivalent. So, tell me, what is 13 times 9? Did you get 117? So this is a 117 on the bottom, 117 on the bottom, right? And then this would be 13. This is 45. Is that right? So therefore, you have a 13 minus 45 over 117, which is a negative 32 over 117. Did you get this answer? Negative 32 over 117, right? Did you know what's the meaning for this? Because this is a pizza, and I cut it 117 pieces. 117 pieces, right? Then therefore, the same component, and they can do the subtraction. Is that clear? All right. And the next time, if I ask you, what is the common denominator? Can you answer like this? Right? And this is a very important concept. A lot of time you just know, oh, the name, but you don't know what's going on, right? But now you know what's going on. This is very important, okay? Number 4. You have any question for this? Okay. No question, next fraction. I have seen a lot of people have problem with the fraction operation, all right? Fraction, addition, subtraction, multiplication, division, okay? 8 divided by 2/3. Again, here's a question I want to ask you. What is the first step you want to do this problem? What is the first step you want to do this problem? You want to what?
Put it as 8 over 1.
All right, it will be over 1. And then what?
You want to flip the 2/3.
You flip the 2/3, and then like this, and then what?
And then you multiply across.
You multiply. Why? You don't know, right? But today you will know, okay? I will make sure you know, right? Why? This is magic. No, nothing is magic. Have you ever questioned about this when you were a kid in elementary or middle school? You question, right? But you didn't ask. The probably teacher don't know. Because a lot of teachers just pass in this. If they don't know, they just pass. If they know, like you know, then after you learn this, you know, right? Then you would tell your student what's going on, right? Let me answer it. Okay? And I'm capable to do it, right? If not, I'm not able to stand here, right? So now, what's the y? Y, we have changed it, division into multiply, and then we have to flip, okay? Yeah. Before we do this, let me ask you. If I can say 3 divided by 6, can I say 3 over 6, yes or no? 3 divided by 6 is equal 3 over 6, yes or no? Yes or no? How about 4 divided by 2? Can I say 4 over 2, yes or no? Yes. 5 divided by 7, can we say 5 over 7, yes or no? Actually, 5 divided by 7, which is 5 over 7, right? It's the same, right? 6 divided by 5, can we say 6 over 5, yes or no? Yes, okay. This is okay, this is okay, this is okay, right? Can we have a general rule? If A divided by B, can we say A over B, yes or no? Yes. But B cannot be what? 0, right? Cannot be 0. Right? B cannot be 0. But if you take A divided by B, which is A over B, right? Okay. Now go back to here. And then in your class notes, you probably put on a small box like this. This is kind of a conceptual understanding to lead into this concept, okay? Put on a small box, like this. If this is okay, then we can move on to this, right? If not, we have the other practice for this, right? Why I have to do this for small box? Because many students, when I say A divided by 2/3, which is equal, this is A, this is B, A divided by 2/3, they say, no, we cannot do this. Why not? If this is true, and we can make it like this. Why not? And this is also true. This is A, this is a B, right? Even though it's a fraction, but it's a number. Only B is equal 0, we cannot do this. Right? But B is not 0, 2/3 is not 0, right? So this is A, this is a B, right? Can we do that? Yes, we can do that. Right? And next, how can I get rid of the 2/3? I times how many in order to get rid of 2/3? Times what? Reciprocal, right? Which is how many? 3/2, right? Okay, very good. If I times 3/2, I can take care of this, make it as a 1. Are you with me for this? Right? Are you with me for this? If you take a 1/2, you want to time reciprocal. You multiply, and then you got the 1, right? So I get rid of a fraction. Are you with me for this? Okay, good. So, can we just times, times 3/2 for the denominator without times here? No, we can make it as an even equivalent fraction, right? Equivalent fraction concept is this. You times whatever number is on the top, you have to times the same thing on the bottom, you make it as even, right? Now, same thing for here. We got times 3/2. Is that right? So tell me what is the number for here? This is a 1, right? Tell me what it is. This is a times 3, right? Therefore, it's a times 3/2. See, that's why we have from division down on multiplication, right? I tell you what, most of textbook, they skip this very important step. They just jump here and do it. This is not right. We must keep this very important step. Are you agree? You have better understanding why we have division and times, inverse multiply. Does that make sense to you now? All right. Next time, can you explain to children like this? Okay, good. And then next, I have not finished yet, right? So I need to do the calculation for this. So therefore, okay, now here is one answer I have found from the student. All right. What she got is this. The answer, she take a 3 times a, which is only 4. She take a 2 times a, which is 16. What's wrong here? Are we supposed to times denominator? No, this is misconception. This is a misconception, right? That's why, teaching fraction is difficult. Because so many detailed combinatorial rules, so many misconceptions there, right? We only take a word. We keep the denominator, and then the reason we're not doing this because we take a actually over 1. Is that right? And then times what? 3/2. Numerator times the numerator over denominator times denominator. That is the meaning of a fraction multiplication. Does it make sense to you? So therefore, we have numerator times numerator 22. Denominator times denominator is 2. So the answer is a 12. So this is a misconception. Right? Another college student also doing this. Can you believe that? Because they have a misconception for this. If they understand this, they will not do this. Alright? Is that clear? Okay, good. So I answer you the question why we have times the inverse, right? Change into the fraction, multiplication, division. We change it into the multiplication and then times inverse, right? So, and then we figured out this, right? We got a 12, right? So, here's another question I want to answer. You see, so many questions, right? So many misconceptions, right? Teaching elementary school it's not an easy job. There's so many details, so many things we need to cover, right? But important thing is you need to have fully understand in order to help the children, okay? So a divided by 2/3, and then the answer is a 12. And the kids will say, teacher, no, that's not right. How come you have a and divided by something, a get a number is get bigger? Divide is supposed to be get smaller. How come divide is get bigger? Can you tell me an example? I say, yes, I can tell you an example. Tell a story of this. But this is true. is true. You take a whole number, you divide it by a whole number, you get a number smaller, that's for sure. But not exactly the fraction. Fraction can be the number can be a smaller, and fraction can be a number be a bigger. Right? Because you are dividing a fraction. You're not dividing by a whole number. If you divide a whole number, it's different, right? So we need to answer the question for this, and we need to tell the story for this. Right? Now how can I tell the story for this? 8. What can I say 8? Can I say 8? I have 8 pizza, right? Okay, so I'm gonna draw 8 pizza. 1, 2, 3, 4, 5, 6, 7, and 8. 8 pizza. Right? I have 8 pizza, right? Then divide. And I want to share. I want to say share. Give it a meaning. Divide, that means a share. 2/3, right? 2/3, that means what? Everyone share 2/3, right? Everyone share 2/3, right? Then 12, that means how many people we can get, right? Okay, write it down in class notes, please. This is a very important concept, please. I have 8 pizza. I have 8 pizza. And everyone I like to share 1/3. Everyone I like to share 1/3. Right? And how many people I can share? And I'll prove this to you. This is 12 here, okay? So here 8 divided by 2/3. 1, 2, 3, 4, 5. Alright. I want to divide it by 3 portions for each one because this denominator is 3, right? I have 8 pizza. I want to share everyone 2/3, and then I put on the 3 pieces because denominator is 3, okay? In order to divide, okay? So I have 8 pizza. I want to share 2/3 for each person. That's the first one. Okay, 2/3. Is that right? Does that make sense to you for 2/3, right? The first person, you got a 2/3, right? The second person got 2/3. Is that right? 1/3, or 1/3 and 2/3, right? And then 3, and 4, and 5, 6, and then 7, 8 people, 9 people, 10 people, 11 people. Did you see that's 12 people? Is that right? Did you see there's 12 people? So I have 8 pizza. Everyone share 2/3. And how many people I can share? I can share 12 people. Does that make sense to you now? Can you tell a story like this? Right? So therefore, I have a pizza divided by pizza is not pizza. I have a deep pizza divided by a pizza, which is people. Coming out how many people are there? So that 12 is a people, it's not pizza. Does that make sense to you? If you tell the story like this, and that helps kids better understanding the concept, okay? This is number 4. Number 5. Number 5. We have a lot of people make mistake for this problem. And many of people find out the answer by using this method. Sometimes this method is working, but sometimes for division is not working. tell you why. A lot of people say, oh, I want to do 2 minus 2. A minus 2 is 6. And then 4 minus 2 is 2. And so therefore, what's wrong here? This is not correct way to do. Look, you take A divided by 2. Is a 6, right? But here is a negative. One is a positive, one is a negative. It's kind of confusion, right? It's not logical anything. Not logical. So this method is not working, completely not working. If you do the divide, you do the subtract, right? You have to consistent. This is subtract. This is a negative, and the next one has to be negative, right? Cannot be like this, no logical. So this is not working, right? Now, how can we do this problem like this? Again, we still can do decompose. Before I teach in this concept, I think I will go over this. Before I do it decimal, I will go over whole number first, okay? 4 subtract 4 minus 6, how many? -2. Can I tell the story for this? I have a $4 in my pocket, right? And I want to get an ice cream for $6, right? And then how many dollars I still owe for the store manager? $2, right? Can we decompose this concept? I have a $4, and then since the 6 is 4, and then plus 2, is that right? Right? And then 4, I have enough. And this one, I don't have enough, right? So therefore, I have a 4 minus 4 minus 2. That's why I don't have a $2 enough for this concept. Does that make sense? All right, good. Can you do a similar way for this? 5 minus 8. Take a minute. You have a $5 in your pocket. You want to spend $8 for a toy, right? How much dollar you don't have enough? $3 not enough, right? Can you say I have $5, but here I have a $5 enough, right? $5 enough. How many dollars are not enough? $3 not enough, right? That's why we have a -3. Is that right? Okay. If this is okay, this is okay. Can we do this? I have a $4.80 in my pocket, right? And I want to spend $6.20. All right? $6.20 on ice cream, right? How much dollar I don't have enough, right? Can you do the similar way like this? 6 decompose 4.8 and one number. What did you get? This is a 4.8, and then this is how many? 1.4. This is how much money you don't have enough, right? This is how much money you still need to get from your bank, right? It's not a negative 2.6. If you do this way, it's not completely not logical because one is positive, the other negative. It's not working, right? You have to do the way like this for the decimal operation. Does that make sense to you guys? Right? One more problem for today, okay? Number 6. 7a divided by 5. So now, this time, you can just flip and multiply, right? because you understand the concept, right? So therefore, 7a times 1/5. So therefore, numerator times numerator, which is 7. Denominator times denominator, which is 40. 7 all around. And we will talk about, the rest of the problem next time. Okay?